Good morning, guys. So, this is me again, Nadsel from Batanggenyong Australiano Vlog. So today what I'm going to present to you is all about electrical boiler making. So this drawing is part of the job of the electrical boiler making. So these three cuts is the one that we widely use on site. And this cable tray is for heavy duty cables that we use on mining and oil and gas construction site. And this one is considered to be one of the highest paying job in Australia as well. So that one is looks easy to do, but you need a good formula as well to do that one. Okay, by the way, I would like to thank my three good mates. They are the master boiler maker for electrician, for electrical. That is, thank you for paring Franco, paring Ruben, and paring Eric for this useful information as well that we are studying right now. So this one is for the three bends. Three 30-degree cut and is equal to 90 degree. Okay? Using 200 radius. And that one is one of the sample after the installation. Next one, then ends up look like that. So that's 90 degree. Then bend whatever the required degrees it is. Then straight, then another bend again on top. Okay, that's another 90 degree bend in here. And the side view of that picture. And this is how to make a layout. That's a bit dark, so I'm going to show you another one. Okay, that is what you need to do to mark out the cable tray. See this one? This one is the angle, the required angle that you need. This is the center. So from that center, you need to measure, let's say 35, from there 35. Then this one is the radius, distance. Okay? And this, how it ends up, looks like. Here to there, that is the radius, That's after the cutting, eh? And make sure when you cut 90 degree, you need to make sure that you have these two rungs in the middle. Because this one, those two are the one who is where the cable need to be attached. So don't forget to cut and reweld this rung in the middle. Yes, another one. That's the closer. That's one of the closer look on the cable tray 90 degrees, and that's where the welding is. One weld there, and one weld here. Okay. Speaking of welding, to have a good welding, you need to cut, or you need to have a good preparation. So what I mean is, on the mark out, you need to make sure that your cutting is straight, so that when you bend, there's no gap leave in there. Otherwise, really hard to weld. Because this material is very thin. I think this one is only 2 millimeter thick. And to weld this one, much easier if you use 2.5 electrode using 60 amps. Okay, so it's up to you if you want to use electrode positive or electrode negative. So, but for me, I prepared electrode negative because this one is very thin materials and that one is galvanized as well. So much easier if you use electrode negative, but still it's up to the welder's technique. So that's the sample. Okay, so I'm going to give you the formula now. The formula that we need to use to cut that one. So to cut that one, to cut that 350 degree bend, I prepare some couple of formulas here. This one is dark, but I'm going to show you the clearer version of that one later on. Okay, so let's say we're going to cut two bends, 200 radius. So that's 3 cuts. One cut there. 200 radius, 200 radius there. From that end to that end of the radius 650, the radius is 200. And from that radius to the other end of the radius 2300. And from the other side is the same, 200 radius. From the end of the radius to the end of the cable tray is 650. So for example, if this one is 300 mm from the end to end and 1000 from that end to the end of the cable tray, same as the other side. So how can we get the computation and the techniques that we need so that we can cut 2 radius in one set of cable tray? So here it is. So to find this 650, so 850 minus 200 radius is equals to 650 mm. To find the 2300 mm, so that 2700 minus first radius and minus second radius is 2300. And the last one, 850 minus 200 is equals to 650. So that is 650. And the next one is 2300. And the next one is 650. Okay. So how to find this angle? Like the one, 40, 40. So because that is 3 bend, the formula is 90 degree, for 90 degrees, so 3 cuts of 30 degrees. So the formula is always, we always need to get half of the degree. So half of 30 degrees is 15 degrees. Because we need to divide that 90 into 30 degrees. 30 degrees, 30 degrees, 30 degrees. Cut into 3. And that degree we need to cut and we need to get the half of that 30 is 15. So half angle tangent times width. So 15 degree times tangent times 150 ends up to 40.19. That's where it is. 40 from the center, another 40. 40 from the center, another 40. 40 from the center, another 40. Okay? How about this 146? How to find this one? Okay, here it is. So for this bend, because this one is cable tray 150, so I need to use bigger radius. So I use 200 radius on that one, for 200 radius. So the formula is radius times 0.732. Why 0.732? Because this is the constant that we normally use for 3 cuts of 90 degree radius. Okay? So 200 times 0.732 is equals to 146. That's where it goes, 146. Okay, so we need to start our layout now from the start. So let's say this one. From the end of the cable tray, you need to measure 650. From that 650, from that tip of the angle, you need to measure 40, center 40. Then radius 146. Then again, another 40, 40, another 146. 40, 40. So that ends up 1, 2, 3, 30-degree cut. Then from there, you need to transfer this marking on the other side of the tray. So from there to 2,300 up to that end of the angle. From that end of the angle, 40, another 40. Radius 146. 40, another 40. Radius 146. And 40, another 40. That's the end. From there, the end is 650. Okay, so it ends up that the total length required for the cable trays that you need to use is 4,667.88 mm. Now, why do I need to use 200 radius? So the radius is depends on the tradie who is going to work on the job. But for me, I prefer to use 200 for the bigger cables. And we prefer to use 150 radius for the smaller cables, so that the cable doesn't stress enough. Okay, we need to make sure that the cable is not stressed because of the bend. So on site, we normally use 150 size cable tray, 450 cable tray, the width, and another one is 600 mm cable tray. So it's up to the welders on how to use their radius according to the needs. Okay, so the next one is how to find the 30-degree angle. Okay, so let's say our angle is 30 degree. I need to adjust this one. Yeah. Okay. So let's say the offset is 150 mm offset. One support there, another support there, rising to 30 degree. Okay, here's the formula. This one is the basic degrees that we use on site, 30 degree and 45 degree. So the formula for 30 degrees is 30 degree and 60 degrees only is if you're looking for, if the given is 150 opposite, so to find the hypotenuse, h is equals to opposite times 2. And straight away you can find this 300. So if you're looking for opposite, so hypotenuse divided by 2. So that's the opposite, 150. But if you're looking for the adjacent side, so square root of 3 times opposite. And that's the answer. But make sure this one is only for 30 degrees and 60 degree only. So, how to lay out this thing? Okay, for example, so depends on you, whatever measurement you need in this one. For example, this one is 1,000 millimeter. So from that end of 1,000, you need to start your measurement. So the center is From that center, 35, that center, 35. How to find this 35? Okay, this one. Formula. We have 30-degree angle. Half of 30 degrees is 15. Why half? Because we need to get 15 degrees here, 15 degrees here. So, 15-degree tangent times 130 mm width is equals to 35. So, to lay out, 35 from center to end of the angle, center to end of the angle. Then from center of that, you need to measure 300 plus half of the cut, 35. So the total is 335 mm center to center. That's why that is 335. You see, remember our computation here is the hypotenuse is supposed to be 300 only, but this one becomes 335 because of the another half from this. That's how you lay out your cable tray for 30 degrees. Okay, now we're going to proceed to how to find the 45-degree angle. And this is how you get the 45-degree angle. For example, another 150 offset. So, one support there underneath of the cable tray, another support there underneath the cable tray. Required is 45 degree. 130 mm width. So, the formula is to find this hypotenuse. 150 times 1.414 is equals to 212. That's because that's 45 degree. So that's the constant that we use, 1.414. Okay, and to find the angle, so half of 45 is to 25.5. Tangent times 130 is equals to 53. So 212 plus 53 is equals to 265 center to center of this to that. Same thing. 53 from the center, another 53. So from the center, you need to measure 212 as a hypotenuse, but you need to add another half of the cut, which is 53.8, so it ends up 265.8 mm. So that is how you cut your cable tray. And as I mentioned before, make sure that you cut your cable tray straight, otherwise struggle to weld. Okay, so sometimes we need to use our sokotowa on site, which is sine is equals to opposite over hypotenuse, cosine is equals to adjacent over hypotenuse, and TOA is equals to opposite over adjacent. But most of the time, we use tangent, which is TOA, opposite over adjacent, because the given, most of the time, the given is on the adjacent side and on the opposite side. And I think that's it for today. And please leave some comment if you want to ask something, and if you have some additional information that you want to include. Please continue to subscribe my YouTube channel, Batanggenyong Australiano. Please like and share. And see you on my next vlog. Thank you. Bye-bye.